So 5.4, derivative of exponents. And I don't mean like x squared, I mean like e to the x. And yes, I will focus that, because that's, there we go. It's another one of those days where it's one new rule. So yes, it's something new you have to learn. The rule itself isn't that hard. It's just that it's one more, and we got to know all the stuff previous to it. Derivative of e to the u. This is probably our favorite derivative, if you can have a favorite derivative. Because the derivative of e to the u is e to the u, but then chain rule times du dx. If you like the orange triangle thing, the derivative of e to the orange triangle is e to the orange triangle times the derivative of the orange triangle. So in some ways, this is like the easiest new rule that we'll learn. Like, it's just the same thing and then chain rule. So the big deal for this was what u is. That's how we make these problems complicated. So let's find dy dx if y equals e to the negative 2x squared plus 3x. So dy dx is e to the negative 2x squared plus 3x, but then times the derivative of that exponent. Pick on some people here. Tierney, what's the derivative of negative 2x squared plus 3x? Yes, very nice. That answer's not right, though. And it's not because Tierney was wrong. Tierney was right. I wrote it down intentionally not quite right. Do you know what's wrong with that answer? I don't need to put it over dx. This is d triangle dx. This is du dx. That is the derivative of the exponent. It's a subtle thing. Right now, e to the negative 2x squared plus 3x, what's it being multiplied to? Right now, it's only being multiplied to the negative 4x. I've got to put parentheses on that to make sure it multiplies to all of it. There was a problem kind of like that earlier on a test, and a few of you didn't put parentheses, and you were mad because you lost the point, but it wasn't accurate without the parentheses. And that's why we would normally, I mean, that's how it shows up when we do the chain rule, but when we rewrite it, we usually put that at the front, but put it in parentheses to make sure all of that is multiplied to e to the negative 2x squared plus 3x. Number 2, y equals x squared e to the negative x. Emily, what big picture, what rule are we thinking about first here? Can't bring down the 2 unless this was natural log of x squared.
Oh, okay. Product?
Product rule, good. So I need to set up a product rule problem. again, today's new information isn't really that hard, so this is a great section to review all the old stuff in to make sure we remember product rule and chain rule and power rule and quotient rule and trig rules and all the other rules get mixed into today. And again, you can product rule in place, but since we're kind of new to this exponent thing, maybe we should slow down a little bit. Emma, what's f prime? Melissa, what's g prime? Good. Good. Keep e to the negative x. That doesn't change at all, but the derivative of negative x is negative 1. So that's not wrong. I would just rewrite it with the negative in front. So that's the details, right? There's all these forest and trees problems. That's the trees. Back up, view the forest. We're doing product rule. So f g prime plus, whoops, I did f prime g, but it doesn't matter since we're adding. Say that again? You could write, I think this is what you're asking, you could write that as 1 over e to the x. Is that what you're saying? Yes, you could do that. In fact, if you'd have done it up here, you would have been doing the quotient rule. So yeah, you could, and you could still do it here, and it wouldn't be wrong. You guys have experienced CalcChat enough to know that, sure, this is an okay free response answer. The CalcChat wants to go the extra mile for us. What could we do to get to the multiple choice answer? You know what CalcChat's going to do? Factor out whatever we can. So definitely an e to the negative x can come out. Anything else? One of the x's can. So x e to the negative x, 2 minus x. And in here we don't mind negative exponents, so that's an okay answer, and that would probably be the multiple choice answer. But to Andrew's question, I suppose they could try to be tricky and write it where they fix the negative exponent, and that would be okay as well. So I'm not sure which one of those would be the multiple choice or CalcChat answer. Number 3, 2 e to the 3x over x squared plus 1. See it. 2 e to the 3x over x plus 1. What rule? Let's pick on everybody today if we can. Sarah, what rule are we thinking about when we see that? I bet you would have done the quotient rule. So I'm going to press pause and let you try that one, because I bet you would be just fine for that. One thing that I don't like about my answer right there, it's not really my answer, it's just the work that I've shown. There's something that's not quite right. And maybe only a math teacher would pick up on it and frown upon what I've done. Do you see anything that doesn't look exactly like maybe it should? I don't need parentheses. I mean, there's other places you could put parentheses that wouldn't be wrong, but this is all okay. Maybe this would be extra misleading if I wrote that. Yeah, I didn't say what that is. It's just kind of floating around, and especially if I write it like that, that's how we write things to mean, no, this is just what y is, but that's not what y is. This is dy dx. Now, we all kind of know that, but But a grader might not pick up on that. You got to tell them what you mean. And so when you take a derivative, make sure it's clear that you've taken a derivative. Especially important later on when we get to the end of a problem. And we've seen this already. We got to go back and plug something in. So you need to have it labeled so you know which one to use. Mark, this is a safe stop. But if we wanted to get fancy, what could we factor out of the top?
Couldn't we get rid of the x plus 1 and cancel it with 1 at the bottom?
Oh, you want to cancel one of these. What do we think about that? There's not one in this term.
Okay.
So, man, it's sure inviting, especially when I write it one right over the other. It's like, but no, because it's being subtracted with this term, and this term doesn't have any. From the 2 and the 6, I can take a 2, and then they both have an e to the 3x. And then let's just be careful about what's left. So on the first one, there's a 3 left, and an x plus 1. And on the second one, this is tricky. I'm glad I worked this problem, or did this one. Because what's left if we take 2e to the 3x? 1. Do you know what the mistake is that people make? They just say, oh, we took it all, it's not there anymore. Like, well, you took it all, but if you distributed it back, you need a 1 there, kind of hold its spot. And one more, if you really wanted to clean it up. But you would need to if you're looking at a multiple choice answer. Distribute the 3, and then collect the 3 minus 1 is 2. So 3x plus 2 over x plus 1 squared. Again, it's one of those where safe stop answer to multiple choice answer, maybe not so obvious. Like sometimes as you're working tests, you get your first answer and then you start looking at the multiple choice and trying to see, well, which one matches up. I don't know that those are obvious equivalents. Like, there's a little bit of intermediate work that's got to be done to get from here there. All right, let's do one more example, and then we'll do one from the homework together, just to get us started. So example number 4. Y equals natural log 1 plus e to the x over 1 minus e to the x. Why? Like, tell me some rules that you see before we do anything. Just tell me some things that we have to know to work that problem. So maybe quotient rule, although we think there may be around it. What else? Yeah, I can do some algebra stuff on that. And even after I do algebra, I still need to know the natural log rule and the e to the x rule. And maybe quotient or algebra. Now, we'd rather do algebra than quotient. So let's do algebra first. So natural log 1 plus e to the x minus natural log 1 minus e to the x. So dy dx equals, let's see, put you on the spot because this is a tricky one here. What's the derivative of natural log of 1 plus e to the x? Let's back up and think about the orange triangle here. You got it. Good. Good. The original goes in the bottom, the argument goes in the bottom, the derivative goes in the top. He said times 1 because he's thinking about the chain rule. Obviously, if he didn't include that, that would be fine. Well, he took the difficult one. Now we can just follow that pattern. Lauren, what's the derivative of natural log of 1 minus e to the x?
1 over 1 minus e to the x times 3 e to the x.
Good. Perfectly acceptable safe stop. But we can do a little bit of cleanup here. The minus minus becomes plus. But a multiple choice test, on your multiple choice test next week, that's not going to be the answer. Emily? We need to get a common denominator. Very nice. And I know CalcChat does this all the time, and it's annoying when you have to do it. I'll grant you that. And that's why, as much as you generally like multiple choice problems, maybe you're starting to like free response problems better because you don't have to mess with, oh, that's algebra stuff. I know how to do that. Like, well, yeah, do you? Like, you're supposed to. So Emily's right. We need a common denominator. So the first one needs 1 minus e to the x, top and bottom. And the second one needs 1 plus e to the x, top and bottom. So I got the denominator fixed. It's the common denominator, so I'll just write it as... I'll just write the denominator once because it's the common denominator. That was the point of doing this. So in the top, I've got e to the x minus e to the x times e to the x. Yeah, right. You're like, no, not 2e to the x. That would be e to the x plus e to the x would be 2e to the x. Okay, there are two options. It is e to the x times e to the x, so that does mean e to the x squared. But that's the same thing as e to the 2x. So either would be okay, but it's probably better to go e to the 2x. So minus e to the 2x plus e to the x plus e to the 2x. It is gross, but at least something nice happens here. Wait, they don't all cancel. E to the 2x's cancel. This is all of your Algebra 2 review in one problem here.
I said 2e.
That's right. You were just ahead of the game.
I originally wrote down 2 to the e of x, and then you started multiplying everything out, so I erased it.
And you would have been right, because e to the x plus e to the x, 2 e to the x over 1 plus e to the x, 1 minus e to the x. Blah.
So you said we are going to have one like this?
Yes. On the multiple choice section, even, to force you. You're right, because if it wasn't on multiple choice, none of you would do that, and none of you should. Like, if it's free response, that means, say stop when you can. Like, you wouldn't do this if you weren't forced to.
Are you going to give partial credit?
Yes, I almost always give partial credit on multiple choice test, as long as I see some work. And so this would be another great example where hopefully everybody would get to this step. And I would see that and think, okay, they know their calculus, so now they've got 3 of the 5 points or whatever. And then, can you algebra your way into the final answer?
Can you explain how you got like negative e to like the 2x for like the first one when you're multiplying e to the x times 1 minus e to the x.
So this one?
Yeah, that one.
So we're distributing e to the x to both of those. E to the x times 1 is e to the x. E to the x times e to the x, that's what we were doing over here.
Oh, and then you just carry on the negative.
And the negative, yeah, the negative just carried in. Oh, you know what? Those are conjugates. So if we multiply those out, some things would go away, and we get 1 minus e to the 2x. Whoa. Conjugates, powers, natural logs, exponents. About to say what a great problem, but you're already frowning at me, so what a challenging problem. We'll leave it at that. All right, page 352. 25 to 28 all, because that's a matching section. That's just a review of e to the x graphs. 33 to 49 odd. 55, 57, 63, and 65. So wherever you do your homework, let's do number 65 together, because we got 10 minutes left to knock one out. So just start your homework with 65, and that'll be okay. If that really bugs you, then just put it at the very end and try to leave enough space. I don't know. Some people, they just got to have their homework in order. Find the equation of a tangent line to x e to the y plus y e to the x equals 1 at 0, 1. No. So what's it take to do a tangent line? Let's big picture first here. What do I need? Slope and a point. How will I find the slope? Derivative at the point. And the point, which they just gave me, so that was nice. So I know the point. I need to find a derivative. And then some of you messed up this step on the test, and it's once you find dy dx, you got to plug in the point so you know the slope at that point. Whatever you get for dy dx, that's not enough. You got to plug in the point to get the value for that. So let's see here. What rule is going on? What rule isn't going on? But what do you see first when we have x e to the y? Product rule. And product rule again. So let's go one at a time here. So f prime and g prime. Natalie? Oh, you got the easy one. What's f prime? 1. Nikita, you got the harder one.
E raised to y times dy dx.
Very nice. We got implicit differentiation going on. But Nikita at least still remembered how to do that. So yes, e to the y is the derivative, but chain rule dy dx. So let's see, that would be x e to the y dy dx plus the other way around e to the y. And now we need to do the same thing for the other piece. And I'm out of popsicle sticks. Everybody answered a question today. Andrew, what's f prime if f is y? Good, dy dx. And I'll handle g prime, e to the x. So fg prime y e to the x plus the other way around, dy dx equals, don't forget about the other side, what's the derivative of 1? 0. Okay, algebra fans. Let's see. How much can I do at once? I'm going to move over the stuff that doesn't have a dy dx on it. And then what am I going to do with what's left? Take out dy dx. I'm trying to skip some steps here. So I'll factor out a dy dx. So dy dx is negative e to the y minus y e to the x over x e to the y plus 1. Is that my slope? That's right. That question's a little bit ambiguous. Yes. Is that what I'm gonna plug into the tangent line equation?
Yes.
No. Why not? Right. I need to find the slope at the particular point. So yes, it's my slope generally speaking, but I need the slope at 0, 1. So I can't just plug that big chunk in for m. I need the actual m, so I'm going to plug in 0 and 1. Emma?
Okay, so how did you get the little dy dx you have circled? How did you,
Where did it come from?
yeah, isn't there be something else with it?
There's a, oh, did I mess it up?
I don't know. Maybe I missed it. Because I got e to the x times dy dx.
Yes, because I don't know what I was doing. Y e to the x, e to the x dy dx. Good catch. So that means this is e to the x, and this is e to the x. And I'm going to say I got messed up because I wasn't able to put f prime and g prime under f, because I wasn't neat is what messed me up, is what I'm going to blame it on. It's still my fault. But if I'd been neater, I think I would have had a better chance of getting it right. Yeah, I messed up the product rule.
Wait, can you explain that? So I'm confused.
So f is y, f prime is dy dx,
Okay.
g is e to the x, g prime is e to the x. Product rule is first one times derivative of the second one plus second one times derivative of the first one.
Oh.
I left off the second one part. Yeah. Now I can plug in 0 and 1. So negative e to the 1 minus 1 e to the 0 all over 0 e to the 1 plus e to the 0. That's lovely. What's e to the 0? It's not nothing. It's 1. And then in the bottom we have 0 plus 1. So there's my slope. Negative e minus 1. What a lovely slope that is. So y minus 1 equals negative e minus 1 times x minus 0. That's why we did that together. And one less working problem to do.
So you can have a slope that has e in it?
Sure, because this is, yes, e is weird, but that's still just a number. Negative 2.7 minus 1 is negative 3.7-ish. Yes, we're okay with that as a slope. We would not be okay with e to the x or e to the y as a slope. We need to plug it in and get a value for it.